In this video, we are going to explain the basic concepts about Bezier curves in order to understand VM objects. If you already have prior knowledge on this topic, you can skip this video. Imagine 2 points in the space, P1 and P2. Join the points along a straight line and put another point on the line, which we will simply call Q. We define the parameter t as the proportion between the distance of the 2 points. If t is 0, then q will be equal to p1. If t is 1, then q will equal p2. The mathematical function to find the point q is easy to deduce. First, we define a reference system and define p1 and p2 in this system. Then we define the vector p2 minus p1. Then we can use the t argument to locate the point q. Using these definitions, we can deduce the function that defines the point q. However, in textbooks you will not find it this way, but like this. This function is known as lerp. Once we understand what lerp is, we can add an extra point, which we will call p3. Now, using the same parameter t, we are going to define 2 points. One point will be between p1 and p2, and the other will be between p2 and p3. Now, let's use those 2 new points as endpoints, and add the last point that also depends on t, which we will call point q. The curve that arises with the movement of point q varying the parameter t from 0 to 1 is known as quadratic Bezier curve. We can understand this curve as a nesting of lerps. We will not do the algebra here, since you can find it in any Bezier curves manual. I will leave you an extensive bibliography in the course resources. Points 1, 2, and 3 are known as the control points of the Bezier curve. Now let's add another point and repeat the same process. In the end, we will have this curve, which is known as the cubic Bezier curve. Points 1, 2, 3, and 4 are known as the control points. Points 1 and 4 are known as extremes, and points 2 and 3 are known as handle points, or Bezier handles. The function of the curve, once all the algebra is done and grouping terms, is as follows. However, Manim already provides us with a function that returns the function of the Bezier curve associated with the set of points. This is the most widely used Bezier curve in the vector design industry, since every curve can be approximated using cubic or quadratic Bezier curves. In Manim, all curves, that is, beam objects, are cubic Bezier curves. If you want to delve more into the subject, I recommend you see the following web page. It's very complete. I also recommend watching the following video to give you a better idea of how Bezier curves are used in the industry. We will return to this topic many times, so it is important that these concepts are well learned. Now you can continue with the course.